These are the answers to the case study by Chris Geisler, Soham, and Neil. The case study was about sex testing in women athletes. The athlete won a silver medal in the 800-meter race at the 2006 Asian Games, but afterwards her sex was questioned. They were unsure of her gender. So here's a little background story, which I'm not going to go over. Sex in humans is determined by anatomy and physiology. Anatomy, as in the primary and secondary sexual characteristics, such as genitalia, whether you have gonads or ovaries, body hair, and pelvis shape. Pelvis is wider in females. There's also physiology, which is the function and interaction of the sex organs, including concentrations of sex hormones such as estrogen, progesterone, and testosterone. So we know that in females there's usually more estrogen, and in males there's usually more testosterone. So these are two ways that sex can be determined in humans. So here's the first question. Imagine you're a member of the committee assigned to determine whether Santhi is female. Here are possible results, and we do not know the real results. So she has female genitalia, she has breasts and pubic hair, but she never has a regular menstrual cycle. So based on this information, we concluded that she's a female. This is because she has female genitalia and breasts. The menstrual cycle, however, is abnormal. Chromosomes are another way that sex can be determined in humans. Females possess 2 X chromosomes, and males possess 1 X and 1 Y chromosome. So we can visualize chromosomes using karyotypes. Chromosomes are only visible when preparing for nuclear division, when the cell is preparing for nuclear division. So a karyotype is a picture of these chromosomes stained during nuclear division. So this is a picture of a karyotype, and in this karyotype, over here, you can see there's 2 X chromosomes, which we can draw this conclusion. It's a female karyotype. Second question. A karyotype was performed on an athlete. Here are the results. From these results, the athlete is male. Over here, there's 1 X and 1 Y chromosome, the Y chromosome being significantly smaller than the X chromosome. If Santhi is a normal female, her karyotype would be A, XX. A female possesses 2 chromosomes, as we discussed earlier. Here's the next question. Looking at this picture of these sister chromatids, they're joined by a centromere. The sister chromatids were formed by replicating a single chromatid. C is correct because sister chromatids are formed by replicating the genetic material in the form of a chromosome. So there was 1 chromatid, or 1 chromosome, and it was duplicated, making 2 sister chromatids. These are identical. This is meiosis. The purpose of meiosis in animals is to produce gametes with just half the parent's genetic material. Gametes are hence haploid. 2 gametes then fuse together from 2 parents, restoring the original number of chromosomes in a fertilized egg in a zygote. So you have a haploid and a haploid. Here's a sperm, and they fuse together to make a diploid 2N zygote, because you have the haploid here, and what is true after meiosis 1? The cells are haploid. After meiosis 1, the cells are haploid, but the genetic material is still replicated. Hence, there's a second round of nuclear division. So after the homologous chromosomes split, which is what occurs in meiosis 1, there are still sister chromatids which need to be divided even further to unreplicate the DNA. During meiosis II, sister chromatids separate. As I just discussed, sister chromatids separate during meiosis II to unduplicate the genetic material. There's no reason to have two identical chromatids or sister chromatids. That's just a waste of energy and cell material. How many possible combinations of maternal chromosomes are possible in a human ovum due to independent assortment during meiosis? So, a quick review, there are 23 chromosomes, and there are two sets of these 23 chromosomes, resulting in 46 chromosomes, different chromosomes. And to do this, you would take 2 to the 23rd power, which results in about 8 million combinations. There's two options for the 23 chromosomes, and that on a calculator will come out to about 8 million combinations. So how is sex determined in humans? Sex is determined by the sex chromosome carried in sperm. So eggs will always carry the X chromosome, but sperm can either carry your X or Y. So the sperm that is donated from your father, if it carries an X, then the offspring will be a female. But if the sperm donated by the father carries a Y, the offspring will be a male. Could Santhi have an XX karyotype and be a male? Yes, if a male determining control gene is carried on one of her X chromosomes. So if she has one of these genes, she can develop gonads, and some people are going to consider her a male with 2 chromosomes because she has the male genitalia. So again, this is a little, it's not perfect because there's multiple characteristics that can determine your sex. So during crossing over, all of the following happen except, so C is wrong, completely wrong. Crossing over decreases the genetic variability in the gametes. That's wrong. It actually increases genetic variability. I'm not going to write it, but increases. How is sex characterized in humans? So far, we talked about sex determination by anatomy, physiology, and chromosomes. One could also use genes to determine sex. Specific genes determine whether an embryo will develop as a male or a female. So the SRY gene, the sex-determining region of the Y chromosome. This is a gene that can be used to determine sex in humans. So early in the development, the immature gonads of the males and females are indistinguishable. But males, in the 7th week of development, the SRY gene on the Y chromosome activates a number of genes, and the gonads develop as testes. While with no SRY gene, in females, the gonads develop as ovaries. So this is how a gene can influence sex determination. So this is an opinionated question here. If you were a member of the Asian Games Medal Committee and Santhi's karyotype revealed that she is XY and SRY plus, what would you do? So the XY reveals that she has a male chromosome set, 1 X and 1 Y, and she's SRY plus, so but she has female genitalia. So I think it would be fair to allow her to keep the medal. She didn't know that she was a male. So, or even if she's a male, it's still debatable. What do you think about requiring gender testing for female athletes in international competition? We think it should be banned because gender determination is so complex. Besides from being complex, it costs a lot of money, and once again, it's opinionated because there's 4 things that can determine sex. So in this case, it was unfortunate. Santhi was stripped of her silver medal, and that's it. Thanks for watching.